here we have number 4. We're asked to find the scale factor of these similar polygons. The scale factor value of k is defined as the new value divided by the old value. So let's just take a look at some values here. Okay. I'm going to compare the bottom numbers here. These are corresponding lengths here. Right, so the new value is 16, the old value is 40. Let's simplify that. I think 4 goes into both. 4 goes into 16 4 times. 4 goes into 40 10 times. That does still simplify 2 over 5. Right, so that would be the scale factor. K is equal to 2 over 5. Again, here the formula is the same as k is new over old. Okay, let's plug in the values here. The new value here, it is, let's look at what's corresponding here. The bottom length and the bottom length. So the new value, it is 5. The old value, it is 25. That does simplify. 5 goes into both. 5 goes into 5 one time. 5 goes into 25 5 times. So the k value is 1/5. This makes sense because from the old to the new, you are multiplying by 1/5. It is a reduction. And notice from the old to the new, it's also going down by a value of 2/5, and that is also a reduction, right? And let's now look at C. It is the same formula as before. K is equal to the new divided by old. Let's now, hold on, let's see. I think I might have to rotate this to match. Does it match now? Yeah, for the most part. And here we go. This is a 30 and this is an 18. So the old is 18, the new is 30. I think 2 goes into both. 2 goes into 15, 2 goes into 18 9 times. Oh, 3 goes into both. 3 goes into 15 5 times. 3 goes into 9 3 times. So here, this is what the k value is. So from the old to the new, it is getting bigger, right? So that is a enlargement. That means that k value has to be bigger than 1, which makes sense because we multiply by k value of because we multiplied by k value of 5 over 3. Because we multiply by k value of 5 over 3. There you go.